This is Algebra 2 at Trig, 5B.2. We're graphing square root and cube root functions. We've already talked about what a square root looks like and a cube root looks like. Today we're going to start to incorporate the a and h and k. As a reminder, we have the parent function. The parent function is f of x equals square root of x. That can be the same thing as x to the half power. That is the same thing as the square root of x, as a reminder. When you think about the domain, you're thinking about numbers you can plug into the square root of x. We can plug in numbers from 0, 1, 2, 3, 4, and 5, and so forth, but you cannot plug in negative numbers. So your domain is always going to be greater than or equal to 0. If you want to use interval notation, you could use 0 to infinity with a rounded bracket and a square bracket. Square around the 0 because it includes 0. The type of answers you're going to get. So if your domain is 0 and bigger, I'm going to pick numbers that are nicely square rootable, all perfect squares. The answers you're going to be getting are also positive values. So your range is going to be greater than or equal to 0. And if you want to use interval notation, you can do that. So graphing, 0, 0 is where the square root graph starts. It's almost like a vertex. It's kind of the beginning thought of where the graph would begin. Square root of 1 is 1. Square root of 4 is 2. 9 would be off our grid, but up at 3. We're heading out that way. That's the graph y equals square root of x. That would be considered your parent function of the square root graph. Looking at a cube root graph, in this case we're calling it g of x equals this cube root of x. You can also call it x to the 1/3 power. So a domain and range for the cubic equation or cube root equation is going to be all real numbers. That means that you can plug negative 8 in there to get an answer. Plug negative 1, 0, 1, and 8. There are no numbers you can't take the cube root of. So the cube root of negative 8 is negative 2. Negative 1, 0, 1, and 2. So we're just plugging numbers in to our function to help us calculate the table. So 0, 0, 1, 1. Now we go all the way out to 8 and up 2. So if you're going to draw this, you shouldn't draw that you're reaching 2 yet. You're at negative 1 down at negative 2. So if we're graphing this, or we're just staying on the grid, you shouldn't reach negative 2 yet because you haven't reached negative 8 yet. This is the cube root graph. That's the parent function. So just as a reminder, these are what the parent graphs look like. From there, we'll be able to reflect, stretch, and translate them. Little reminder, if you're thinking about tables, the numbers that we use for square root graphs are 0, 1, 4, and 9, because those are all perfect squares. Cube roots, we use numbers negative 8, negative 1, 0, 1, and 8, because those are all perfect cubes. So we're going to come down and take the square, or we're going to graph the square root of negative 2 x to the half power. Notice the half power. What's the half power mean? It means a square root. Notice that the half is only affecting the x. It does not get to the 2. It's not in parentheses. So you might call this negative 2 square root of x. So if we're going to think about just the parent function of this, the parent function would be y equals the square root of x. Because it's a square root, we're going to use the numbers 0, 1, 4, and 9. That gives us the answers of 0, 1, 2, and 3, because the square root of 1 is 1, square root of 4 is 2. And we can graph that. And that's the graph, y equals square root of x. So that's your parent function. From there, we're going to apply the negative 2. The negative gives us a reflection over the x-axis. So that means all your points are going to get reflected over the x-axis from where your parent function was. And then the 2 gives us a vertical stretch by factor of 2. So instead of coming down 1, you're going to come down twice that amount. Instead of coming down 2, you're going to come down twice that amount. 3, you're going to come all the way down to 6. So to graph our final one, we can do it with a different color. And that's y equals negative 2, the square root of x. The negative tells us that it reflects downwards. 2 tells us that it had a stretch. And the square root graph tells us that we're curving in just one direction. Now, something we can see here with the table, if you were trying to calculate and make a table for all these values, I often talk about how that's a little middle school and we want to do 11th grade math, so we're not making tables. But you can get away with it. If you were doing y equals negative 2 square root x, you would be multiplying all these values by negative 2. And that's why we're at 0, 0, 1, negative 2, 4, negative 4, and 9, negative 6. By thinking about a third row on your table, you could create that if that was really important for your success. The domain. What type of answers is the blue graph hitting? What x values is the blue graph hitting? Blue graph is hitting from 0 and everything to the right. So x is greater than or equal to 0. We can do it in interval notation. But now watch for the blue graph. The y values are from 0 and down. So that is y is less than or equal to 0. Now when you do interval notation, you always put the value of the smallest number first and the largest number last. So negative infinity all the way up to 0. It includes 0, so it's a square bracket. Now we're going to graph a cube root graph. The 1/3 implies this is a cube root. It's only affecting the x. So if you wanted to write that differently, you could call it the cube root of x. Since it's a cube root graph, we can think about the parent function. So we use numbers like negative 8, negative 1, 0, 1, and 8. The cube root of those numbers, negative 2, negative 1, 0, 1, and 2. And we can easily graph those. And that's y equals the cube root of x. That's a parent function. Now, if you felt that you needed another row to do y equals half the cube root graph, you're welcome to do half of it. But we should be able just to come over to the graph, and instead of going down to -1, you're going to do half of it. Instead of coming down to -2, you're going to do half. Half and half. So this is 1/2 the cube root of x. So you see that this has a vertical shrink. There is no reflection. Vertical shrink by factor of 1/2. Your domain and range will always be all real numbers. You can plug in any x value and you can actually get any type of result. Now we're going to incorporate the h and the k. We've already done that this year, many different types of functions. So now we're going to graph a square root x, or a cube root x. Not worrying so much about the parent function, but going right into the a version of it. The stretch, and it would include a reflection if necessary. We will then translate it h units horizontally and k units vertically. In terms of finding our domain and range, we've talked about doing that with the graph. We can also do that with the equation. If you set what's inside the radical of a square root to 0 and solve it, you can calculate what the domain is. And to determine the range, it has to do with the sign of the a value. So if the a value is positive, if it's greater than 0, then you're going to have y values that are greater than k. That's going to be k, comma, infinity. If your sign is negative, you're going to have an a value that's less than 0. That's going to be y is less than or equal to k, otherwise known as negative infinity to k. You always do the smaller number first, the larger number second, with interval notation. To determine the domain and range of a cubic, well, that's just straightforward. It's always all real numbers. So here we have y equals 3. We have some parentheses with a half that's telling us that everything inside the parenthesis is inside the square root. X minus 1 is inside the square root. Then the plus 2. You need to be very careful on how you write your radical. You need to be sure that you're very clear that the negative 1 is inside the radical, that the positive 2 is outside the radical. Don't be sloppy on how you're drawing your radical sign. Don't stop it short. Don't take it too far. You can use parentheses around that x minus 1 if you like, or you can use a rational exponent. So we've talked about graphing the a value square root x, but when you really start to think about where this is at, that can get complicated without first thinking about where the square root of graph is. So I would suggest either mentally you're thinking it, or physically you're going to write it in here. Y equals the square root of x. You're going to use square root numbers like 0, 1, 4, and 9. And you take the square root of 0, take the square root of 1, square root of 4, square root of 9. So those are the numbers that are square rooting. So you don't have to think so much. Because now we're going to take our a value, which is a 3. That's your 3. 3 square root x. And that would multiply all of those numbers. So 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And that's where your y equals a of x, a square root x, is going to be. 0, 0, 1, 3, 4, 6. It's up 3 times as much as usual. And then 9, 9. And that's going to be y equals 3 square root x. So this has a vertical stretch by a factor of 3. Because the 3 was in front of the radical. Because the 3 was not being affected by the half. Now we're going to translate our graph. 1 unit to the right. It says minus 1, but that's going to be to the right. It's always opposite. But we're going to go up 2. So translate 1 right, or 1 unit right, and 2 units up. So that means we take every one of these points and we move 1 to the right and up 2. Every one of these points, 1 to the right and up 2. So you're no longer going from the origin. You're going from 1 to the right, 2 up. That's your new location. So we have y equals to the cube root of x minus 1 plus 2. Be clear on how you write your equation. What's inside the radical? What's outside the radical? So your domain and range. We talked about doing our domain and range of a square root graph by looking at inside the radical and setting it equal to 0. Well, that is our x minus 1. You can set that equal to 0. You can add 1 to both sides. So you're going to get x equals 1. That's where your domain is going to start. And we've noticed it's going to the right. So x is greater than or equal to 1. You could use interval notation. And for the range, we look at the sign. Our sign is positive. So we're going to use a positive a. We're going to be greater than the k value. Take a look at the graph. You're up at k, which is 2, and you're greater than that. So y is greater than or equal to 2. So the next thing we're going to work with is a cubed root. Because the 1/3 has a denominator of 3, we know it's going to be a radical with an index of 3. The 2 is not being affected, so it's on the outside of your radical. Index of 3. X minus 3 is inside the parentheses. And then the minus 2 is outside of that. This is clearly a cubed root type of graph. So we're going to focus on cube root numbers. And I'd suggest to at least mentally think it, if not physically write it. The cube root of x is negative 2. Cube root of negative 1 is negative 1, 0, 1, and 2. You can graph that if you want, but you would at least need to think those numbers. And I think it's easier if you can see those numbers. So now we're going to take our negative 2 and multiply that to the cube root of x. Now, since we have some data written in there, we're going to do negative 2 times negative 2. Negative 2 times negative 1. Negative 2 times 0. Times 1 and times 2. So that's the graph that we're going to put. At negative 8, we're going to be at positive 4. Negative 1, we're going to be at 2. 0, 0. 1, negative 2. 8, negative 4. That's our graph, y equals negative 2 cubed root of x. So this has a reflection over x-axis. It has a vertical stretch by factor 2. And now it's time. We've got that graphed. That's what our table's telling us to graph. Now we're going to do the translation. We don't manipulate our table to represent a translation. That's why we don't just plug numbers into our original function. We are going to translate 3 units right, 2 units down. 3 to the right, 2 down. And that's going to give us answers that are all real numbers and all real numbers. That means we take all our points and go 3 to the right, 2 down, 3 to the right, 2 down, and you can graph those. You can connect those. And that's y equals negative 2 cubed root of x minus 3 with the minus 2 on the outside. There we have it.